So here we go. A linear equation is an equation that forms a line when you graph the equation. They're often written in the form of ax plus by equals c, which is called standard form. Ax plus by equals c. Now, x and y are still the only variables. You won't actually see the letter A, the letter B, the letter C. You'll see something like this. 5x plus 2y equals 10. That's the kind of thing you'll see. Okay? So it's in that form, but you won't see the A, B, and the C. Now, C is a constant because it's not attached to a variable. Okay? So it'll be an x term, a y term, equals a constant. That's standard form. We hardly ever use standard form, but they love putting that form on standardized tests. So if any of you guys are going to take the ACT again, or you're going to take the Compass, you're going to have to deal with standard form. You're going to have to. So let's learn to deal with it. Now, do what? Yes, it is. Yeah, and I don't know. I didn't do a really good job rearranging the learning targets to fit the lessons. So this lesson is going to have 5 and 7 in it, and we're just kind of skipping 6, and we'll come back to it. So what we're going to find first are the x-intercepts and the y-intercepts, okay? And then we're going to use those to graph the function. So we're going to start graphing today. It's probably been a while since you've graphed a line this way. It's a really easy way, but it's a way that doesn't work on a graphing calculator, and that's what most of you guys have been using lately, and that's fine, okay? All right, so we've got standard form. Now, before I go to that, let's talk about the x-intercept and the y-intercept of a line. We know that when we have this form of a line, that's called slope-intercept. And we just got through working on the fact that that's the slope, which means that's the intercept, but it's the y-intercept. And tell me what y-intercept means. Where it crosses the y-axis. So if the y-intercept is where it crosses the y-axis, what's an x-intercept? Where it crosses the x-axis. Which means if you can figure out these intercepts, you'll know 2 points on the line, you can draw the line. Okay? So that's where we're heading with all this. Make sense? All right. Now, just so that we don't try to apply linear equations to things that aren't linear, let's take a look at these. It says determine whether each equation is a linear equation. We're not going to write it in standard form. Here's how you tell. It'll have an x and a y, or if it's a horizontal line, it'll just have a y. If it's a vertical line, it'll just have an x with no exponents. So A is a linear equation. 1A is a linear equation. B, no exponents. But what weird thing that I forgot to mention is happening here on B. Yeah, it's got 2 different x terms, and the x and the y are multiplied together. Does that make sense, knowing that that's the standard form? You can't have an x and a y multiplied together. So that one's not a line if you graphed it. What about 1b? Because of the x squared, that one's not a line if you graph it. So, I mean, on the worksheets I give you, they're going to be lines. But just, again, on the standardized test, ACT or a Compass, you need to recognize if you're dealing with a line or not. Okay? Now, let's get back to the intercepts. So like we just said, the x-intercept is the place where the line crosses the x-axis. The y-intercept is where the line crosses the y-axis. Okay? So look at the drawing I've got here. Group these together. I'll even make it a little bit bigger. That's a big old graph. Let's look at the blue line. For the blue line crosses the x-axis right there, and the y-axis right there. So for the blue line, the x-intercept is, well, that'd be -2 right there, wouldn't it? -2. Or you can even say, and I guess I'd rather say, x equals -2. The y-intercept is, well, it's also -2, isn't it? Right there. Now let's look at the red line. Here's its x-intercept. So that'd be what? -1, 2, 3, 4, -5. I'm just going to say is -5. The y-intercept is way up here. 2, 4, 7. Did I count those right? No, I didn't. There's 2, 4, 6, 8. All right, look at the purple one. For the purple one, what's its x-intercept? 0. What's its y-intercept? 0. Because that one point does both things, doesn't it? That's where it crosses the x-axis. That's where it crosses the y-axis. So the x-intercept is 0. The y-intercept is 0. Look at the green line. Can y'all see the green line? It's this one. What's its x-intercept? Undefined. Doesn't have one, does it? It never touches the x-axis. So, x-intercept, undefined, or, you know what might be better? Remember when we did D and E the other day? Does not exist. What's its y-intercept? 1. Okay, now, if I told you that there was a line whose x-intercept is -5 and y-intercept is 8, could you draw that line? Wouldn't you just come down here to -5 on the x-axis and go, okay, the line goes through there. You'd go to 8 on the y-axis and say, all right, the line goes through there. You got the red line, don't you? So that's what we're going to start doing. We're going to figure out the x-intercept and the y-intercept. Then that's going to allow us to draw the line. All right. So here's how you do it. Write these examples down. You're going to need these. No matter what form the equation is in, to find the x-intercept, make y equals 0. Because, look back at the graph. Look at the red line. At the point where the line crosses the x-intercept, what's that y-coordinate? It's 0, isn't it? So to find the x-intercept, make y equals 0. So that'd be 7x plus 0 equals 5. So that's 7x equals 5. X equals 5/7. That's the x-intercept. To find the y-intercept, make x equal 0. How come? Well, look at the red line again. At the y-intercept up here at 8, what's the x-coordinate of that point? Well, it's 0, isn't it? So, by letting the x-coordinate equal 0, that'll give us the y-intercept. So that would be 7 times 0 plus y equals 5, y equals 5. We found the x-intercept. We found the y-intercept. Well, all you got to do is replace one of the variables with 0, solve it, and you found one of the intercepts. Okay? Let's take a look at number 2. Let's get the x-intercept first. So and you don't have to write this out. I'm doing this to help you, okay? Use y equals 0. So that'd be 3x plus 5 times 0 equals negative 5. 5 times 0 is 0, so that's just 3x equals negative 5. That means x equals negative 5/3. That's the x-intercept. That's where the line crosses the x-axis. To find the y-intercept, use x equals 0. So that'd be 3 times 0 plus 5y equals negative 5. 3 times 0 is 0. So that's 5y equals negative 5. Divide by 5, and y equals negative 1. That's the y-intercept. And then whenever there's not an x and a y, in theory these are easier, but they're never easier. All right, what's undefined? The x-intercept. There isn't one. Y equals 4, that's a horizontal line, right? So the x-intercept does not exist, or undefined if you prefer. And then the y-intercept is that. Every y coordinate on the line is 4. So the y-intercept is 4. Did y'all follow me on that? And like I said, in theory, those are supposed to be the easiest ones, but they just don't seem to be, because students, meaning you guys, tend to forget the exceptions. Horizontal lines and vertical lines are always exceptions, and exceptions are tougher. All right, do number 4 on your own. Anybody get the same thing I did? All right. Let's do a couple of examples. All right, so on the graph paper that I'm giving you, be thrifty with this. There's no need for you to go buy graph paper, so don't go buy graph paper. But let's not waste this either. So keep up with it until we've used up all of the grids, even if that is February. All right, so if you can fit it all onto your graph paper, fine. If you need to do some of your work on notebook paper and then just the graph on the graph paper, fine. Whatever works best for you, okay? I'm good either way. All right, so now, not only are we going to find the x-intercept and the y-intercept, we're going to draw the graph, all right? So for number 4 here, our equation is x minus 1 equals y, which, you know, that's not any kind of a form. It's almost slope-intercept form, but it's written, you know, the two sides are switched on the equation. But that's okay. I can still get the x-intercept by replacing y with 0. So that would become x minus y equals 0. Solve it for x equals 1. To get the y-intercept, replace x with 0. So that'd be 0 minus 1 equals y. So negative 1 equals y. Or better yet, y equals negative 1, right? All right. Now that you've found the x-intercept and the y-intercept, go to your graph paper. X equals 1, so the line crosses the x-axis at 1. So put that point on your graph. And then y equals negative 1, so the line crosses the y-axis at negative 1. Put that point on your graph. Guess what you do with those 2 points? Draw the line. And I don't care how long you make the line. It's not like you have to go to the edge of the coordinate grid. It's also not like you can't go past the edge if you want to. So I'm not going to be grading these to see how great your line is. I'm going to be grading it to see if you've got the right 2 points on there to start your line. Okay? So now we can get the x-intercept and the y-intercept, and we can use those to draw the graph. And like I said, that's not, you know, that doesn't use your graphing calculator. It's probably been since Algebra 1 since you did them this way, but you probably did them this way in Algebra 1. All right, let's do the next one. Number 5 here. This time our equation is 2x minus 1 equals y. To get the x-intercept, make y equal 0. So that'll be 2x minus 1 equals 0. Then we solve it for x. 2x equals 1. X equals 1/2. Then we get the y-intercept. Replace x with 0. 2 times 0 minus 1 equals y. Negative 1 equals y. So how about y equals negative 1? X equals 1/2 for the x-intercept. So I'm just going to have to do my best to figure out where 1/2 is, right? I'm off a little bit, but I think that's as good as I can do. Y equals negative 1. One thing that I don't like about these, when the points are too close together, it's kind of hard to draw the line, isn't it? For me it is, especially using this silly line tool they've given me here. It's kind of hard to make sure it's actually going the right way, but I'll say that it does. Questions? All right. Last one we're going to do together. Number 6. Let's get the x-intercept. That means replace y with 0. So that'll be 4x minus 3 times 0 equals 12. That's just 4x equals 12, x equals 3. Okay? To get the y-intercept, replace the x with 0. So that'll be 4 times 0 minus 3y equals 12. Negative 3y equals 12. Y equals negative 4. X equals 3 is the x-intercept. So we put a dot there on the x-axis at 3. Y equals negative 4 is the y-intercept. So go to the y-axis, put a dot at negative 4, and then draw a line. Like so. Questions?